Alright, welcome to ABC Go Study. In today's video, I will take you through 2019 Wassce Physics Alternative to Practical Work. If you need more videos on physics, you can check the description section, and also forget to subscribe to this very channel so that you will get more videos like this. It is below this very video, the red subscribe button and the notification bell. So looking at question number 1 of 2019 Wassce GCE Alternative to Physics Practical Questions. The diagram below illustrates a what? A meter rule. This is the diagram you can actually see there. The diagram you can see there. So it illustrates what? It illustrates a meter rule of gravity G. That's the G you can see here. The G you can see here. Do you understand? Now, is suspended from what? From a rigid pointer P. So this is the rigid pointer P. Do you understand? Now, the distance x between G and P is what? Is measured and recorded. We are actually told that what? The distance between this very G and P. You know, that's exactly what you can see here. That's exactly what you can see here, represented with x. Do you understand? So the distance between this very P and G, x, it will be given to us in this very question. That's with another slide. I want you to understand how alternative to practicals would look like. You understand? So that you will be able to to get that very best you would like to get in that very examination. So after we've seen this, the next thing you should, okay, let's read the question. Now between G and okay, we've talked that. So the meter rule is what? Is slightly displaced sideways and released so that it performs simple oscillation. Do you understand? So simple oscillation, just like you can see here. Just like you can see here. You understand? That's the what? That's the oscillation. That's the oscillation. To and fro. To and fro. Now, the time t for 20 complete oscillation and the what? The period t of the what? Of the oscillation are determined and recorded. After all this, we will determine this. So the next thing, the procedure is repeated for what? For 4 other values of x. Figure 1a and figure 1b on page 3. So I will show you figure 1a and figure 1b right now. Now this is figure 1a, and you can actually see figure 1b. You understand? Now the usefulness of this very figure is that, especially that figure 1a, you will need to use your meter rule, your ruler. Do you understand? So that means that if you are going tomorrow, or anytime you would like to do your alternative practical physics, you try to what? Try to take along with you your ruler. Do you understand? So your ruler will be effective. It will be important because you will need that very ruler to what? To measure this very distance. So that for you to get x1 now, x1, it will be what? It will be the distance of this very x1 from x1 to what? To G. You know that I was telling you that time that what PG. Do you understand? So if you want to get your x1 now, it will be, you will measure the measurement will be what? The measurement of your meter rule will be from x, this very x1 to G. Okay, let me show you. So it would come towards G. So that's the what? That's our x1. X1. If you want to measure your x2 also, take your meter rule and what? Measure it from this very x2 to this very G. So the distance from this place to this very place will be what? Will be your x3. So the same thing to x2 rather. So the same thing also to x3. You measure this very place. X4 also measure this very place. To measure everything. Do you understand? To measure everything. Now, the next thing now is for you to note this very figure 1b also. If you want to get the measurement, you see, this is what? This is the seconds, right? We have 30 here, we have 30 here, we have 31 here, we have 33 here, we have 32 here, right? If you really want to get that very measurement, you see that what? You have to count the dots between what? 32 and 33. That's the division, right? So if you count them, you see that what they are. We can actually say 9 there. Do you understand? They are 9. So that means that what you just do is that is for you to know that if you have these very the first one will be what 32.1, the second one will be 32.3, and all that till you get to what 33 that you can see here. So that means that what the T1 we can actually see here, the value of this very T1 is what is 32.1. Do you understand? Don't worry, we'll still talk more about that. So let's go back to the question. So the procedure is repeated for what? For four other values of x, just like we've actually seen figure 1a and figure 1b. You understand on page 3. I like the exact slide you saw there the other time. Now illustrate the distance xi and the corresponding times to what like respectively, where I equals to 1, 2, 3, 4, and 5. Okay, the first question you can actually see here is that what? Measure and record xi. Let me quickly show you how you can do this if you were actually given something like this. But before then, note that anywhere you see I, it represents what we mean by 1, 2, 3, 4, 5. Like the I you can see here, xi, the ti you can see here, and the likes. Before I can actually talk about this, we need to what? We need to actually draw a table. So this very table, I've actually drawn a table here, and I've actually talked about S stroke N, where I would talk about the numbers of that very what? Of that very values, of the values. And then you see X, you can actually see X here. That's the X we are asked to find now. Now, to find x1, the value you are going to fix here, this is simply what you are going to do. You are going to what? Just like I told you the other time, the measurement of this very place to what? To this very place. That's why you need a ruler. So go there with your ruler and then take a very accurate measurement. Do you understand? So, and if you need x2, the x2 that should be here also, you what? Make sure that what? You measure from this very side to what? To this very G here. Do you understand? So the measurement, the distance between that very x2 and G will be what? Will be your what? X2 here. Just like that till you what? Till you finish that very this very x5 as well. Do you understand? You just do the same thing. Now, according to WAEC, they stated there, according to what they said after they marked all the questions and all that, and their marking scheme, they said uh this very question should be what? Should be at least one decimal place. You understand? At least one decimal place. So if you actually want to input something in this very this very side that what that you can actually see x, it must be in what? It must be one decimal place. Another thing you should note also is that what is the unit. Don't forget the unit. When I was actually writing the values, I've actually written the unit here. That's what that's cm. You understand? That's the unit. Some people would actually leave this very cm and what? They will not write it here. They will write it with the numbers they should write here. Like now, if I should write something like 1.76. Okay, let me see. 1.76. If I should write 1.7, okay, if I should write 1.7 here, some people will just write 1.7 centimeter because they didn't include it at the top here. Do you understand? But because I've actually included it at the top here, you don't really need to include it while writing 1, 2, 3, 4, 5, the values of these very x1, x2, x3, x4, and x5. I think that should be understood. And let's move to the second question. Read and record TI. Now, just like I told you that time, when I'm talking about that very TI, that's 1, 2, 3, 4, 5 till get to 5. Like 5 till 5. Now, to get this very value, you can just see what they've actually written. Read and record, not measure and record. Not everything. You are not going to use meter rule to get everything. Do you understand? Even there are some times that you would actually, after you've gotten the value, you will need to convert that very value through the scale, they might give you that if you actually measure 5 centimeter here, um our own scale will tell you that what that 5 centimeter should be changed to something like 25 centimeters, something like that. Do you understand? So just make sure you read the question very well, because it is an alternative to practical. It's not the real practical. Before I talk about the next thing, please, if you've not subscribed to this very channel, click the red subscribe button below this very video, and also click the notification bell so that whenever I upload videos like this, you will be able to get them and watch them just for free. And if you need more videos that would help you to pass your exams on physics, on chemistry, and all that, you can check the description section. Now, to start with T1, that's exactly the value you should input here. Do you understand? So let's look at, if you actually check this very one, you see that this is our T1. You've actually been given here that that's T1. This is our T2. This is our T3, T4, and we have T5 here. Do you understand? Now, to actually answer this very question, that's T1 that I told you the other time. If you actually check this, you need to check the what this very 30, you can see here, you have 30 here, you have 31 here. Do you understand? And you also have what, you have 32 here, and you also have 33 here. Now, between these very, you can actually see that the arrow is between 32 and 33. And if you check that 32 and 33, it has actually been divided into what? Into equal parts. And if you check that very lines, if you count that very lines between 32 and 33, you see that what? We have 9 lines there. That means that what? They've actually divided this very that very space between 32 and 33 into 10 equal places. So with that, we can actually say that what? One line will be equals to what? Will be equals to 0.1. Do you understand? So that means that if you count this very place now, you see that what? It is only one line after 32. Do you understand? After this very arrow, that's what? Only one line after 32. So that means that what? If you actually want to record this, so that will be what? 32.1. So let's write that here. 32, 32 point what? Point 1. And it should be what, according to WAEC also, it should be what, it should be at least one decimal places, the one decimal place. Do you understand? One decimal place, that will be the at least. This very T, as you are recording it, it should be what, in one decimal place. Now let's check that very T2 also. I want to make sure you understand this very aspect, because a lot of people lose their mark in this very aspect. And I'll tell you some of the things that WAEC also said. They are like the weaknesses, how they actually expected this question to be solved. And that 2019, some students were not able to solve it exactly the same way they should have solved it. Now, this very T2 also, if you check it, you see that what, it's actually been divided into 9 places like the other one. So okay, 3, 4, 5, 6, yeah, 9 places like the other one. So what we just need to do is to count the number of lines that we can actually see there. And if you start to count this, you see that what, this is 1, this is 2, this is 3, this is 4, and this will be 5. Do you understand? So that will be what, 31.5. So let's write 31.5 here. 31.5. Now let's do the third one. That's what, that's the one you can see here. And if you check it, that's what, this one is actually coming from 30 towards to 31, right? So okay. So if you want to do this, let's count the number of lines that you can actually see there. That's one. You can actually see 1, 2, 2, 3, 4, 5, 6, 7, 8, 9. So that will be what? That will be 30.9. So write 30.9 here. 30.9. The next one, we have what? We have these are T4. Do you understand? So count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Oh, I'm actually out of that very place. That's 1, 2, 3, 4, 5, 6, 7. So that will be what? 30.7. Do you understand? 30.7. So write 30.7. The next one also, that's 30, right? So this is 1, 2, 3, 4. That's 30.4. So just write 30.4 here. 30.4. So that's our what? That's our t in seconds. Now let's move to the next question. In each case, evaluate x square t and t square x. So that's exactly what you can actually see here. That's x square. That's in centimeter square, and we can you can see the second place here. You can actually see what? You can actually see t, and the last one here you can actually see our t square x. Now to solve this very one, it's very simple. You just need your calculator. Do you understand? To calculate this very stuff. Now I want you to note that what when you're actually calculating this very x square, you would get something more that will be more than one decimal place, right? So WAEC would actually need you to understand that it must be at least two decimal places. Do you understand? The reason why I've been saying this is that, especially this very x one now. Okay, let me start from this very x, right? This very x in centimeters here. There will be a reduction of 1 mark if what? If you don't put it to like maybe the value is not correctly measured, that like if it is not like plus or minus 0.1 centimeter to that very measurement that WAEC has. You understand? Standard measurement that they actually have with them. If yours is less than that or more than that, and at the same time it's what it doesn't conform with what I said the other time, that what one decimal place they will deduct 1 mark from that very question. From the if so here they will deduct 1 mark. Here also, if you repeat the same thing, they will deduct another 1 mark. This very place also they will deduct another 1 mark. If you repeat the same thing, they will deduct another 1 mark, and also here they will deduct another 1 mark. Just note that your value, don't be like but if there is a mistake or things like that, actually if your value is plus or minus, is within the range of plus or minus, like their own value, if it is within the range of plus or minus 0.1 centimeter, they will still score you. But the main thing is, note that what it should be at least one decimal place. Do you understand? Now the second one here also, this very t also, just the same thing. Do you understand? One decimal place and all that. They will deduct also one mark from each of the answers. Do you understand? From each of the value. Now this very x square now, x square in apartment of what x centimeter square, you have what you have. It should be at least two decimal place, like I said the other time. And what if you fail to comply with this, they will deduct half mark. So that means that the half mark will be deducted from this very place. This very place also half mark, half mark, half mark, half mark. Do you understand? So like that. Now to get this very big T, capital T, that's our period, right? And we have our period to be T over N. That's the time over the number of oscillation. And we've actually been given in that very question. I don't want to go back to that very question, but you can actually pause that very video and check the beginning section of this video. You actually see that what the number of oscillation should be 20. You understand? So that means that the number of these very seconds that you can actually have here should be divided with the number of oscillation. Should be divided with that very 20 throughout this very place. So let's quickly do that. And I hope you've subscribed so that you get more videos like this. You can just click the red subscribe button below this very video and click the notification bell just for free. Now if you calculate your t, especially that very t1, That's the period, the first period. You would get what? You would get 1.6. Now, if it is two decimal places, you would get 1.61. But if you would like to make it three decimal places also, it is accepted. The main thing is the main thing is that it must be at least two decimal places. Do you understand? Now the second one also, that's 1.575. That's what? That's three decimal places, right? The third one also, that's 1.545. And the third one, the fourth one is what? 1.535. If you use your calculator, you get the same thing as the exact thing I'm actually writing. This one also will be what? 1.520. You understand? That's in three decimal places. So anytime you start with maybe three decimal places and all that, don't change it maybe at three or four, five to what? Two decimal places. No, it must be what? Aligned. You understand? So with this, you get your full mark. And the next one is for you to do what? To do the t square x, and the reason why I can't do 2t square x is that this very t square x is not what? It's not actually if you actually check that very place, you will see that what? T square x here, I can't actually use a ruler to rule it because of how it looks. Do you understand? So, but for you to understand it, I've actually what? Explained it. I actually expressed what you should actually do if you should do it. Now to the next question. Plot a graph x square. So that means this very x you can actually see here. That is in what? Centimeter square. You understand? Uh, Plot that very graph x square on the vertical axis. You understand? And t square x. That very t square x you can see here. You should draw that plot that on the horizontal axis. Now you must start this very you must make sure this very graph starts from what? Like starting both axes from the origin 0 0. So if actually I have x here, I will be able to I will quickly draw the graph. But because I don't actually have the value x, what I will do now is just to take you through how you should have you should do it. Now, according to the question we were given, starting from what? Both axes from 0 0 degree. 0 0. Do you understand? So that means that what? This place we must start from what? 0 0. That's 0 0 origin. I'm sorry, it's not degree. 0 0 origin. Now, we were told that what? We should put t square x on the horizontal axis. So that means that these our x axis here should be t square x. Do you understand? That would be t square x. And then these are vertical axis, otherwise known as the y axis, should be what? Should be the one known as what? Known as x square. Do you understand? So you would have you have your x square here. You have your x square here. So then you can what? You can plot the graph. Do you understand? So just locate where the the two points intersect and what? Like the two of them intersect and what? And put a dot until you get odd. And after that, you what? You would draw this very graph. Now, what you should note about the graph is that what? It should, number one, use a reasonable scale. Do you understand? And I would advise you that after you've used that very scale, try to what? Try to make it known that a Kinikan unit is equals to um it's equals to 1 centimeter, 2 centimeter on the y-axis, just like that on the x-axis, like that, so that what? So that the examiner will understand you better. Now, the second one you should understand also is that what? Is the line of best fit. So this line of best fit would help you to get the slope, and then you get the correct answer. Please make sure it is the line of best fit. Don't just draw any line. Do you understand? Now we'll move to this next question now, which will be for us to determine the slope. And I know you should actually understand that any slope, even mathematics, you should understand that what? It is the change in what? Change in the vertical axis over change in the horizontal axis. So if you're actually talking about slope, let me write that out. Let me write that out. Slope is the change in the horizontal axis. If you actually check that very horizontal change in the vertical axis over, so if you actually check this very vertical axis, you see that what it is x square, right? So that would be what? That would be changing in x square over what? Over the change in what? The change in what is the the x axis? The horizontal axis. The horizontal axis, you can actually say that what is t square x. You understand? So you write t square x. So that's the change. So that's actually how you get the slope. You understand? And we are talking about this very next question also, that says that we should evaluate k equals to, where we have k equals to what? K equals to 4 pi square s. The meaning is that what? 4 pi square slope. So the value you would get as the value of this very slope would be used here. You just insert that. If you actually get, okay, let me just say that you will not get the same thing, but if you actually get something like this very slope, maybe 5, you understand? So you just input that very 5 here. It will be what? It will be k equals to what? K equals to 4. What is the value of pi? You know, pi equals to 22.7, 22 over 7, right? So 22 over 7. Make sure you get the square of that. Now, what is the slope? I said we should use 4, so just use 4. And with that, you can actually press your calculator and wait, and you will get the answer. Do you understand? So that's it, actually what I mean by what you should understand by that very key. Do you understand? So that means that if you don't get the value of this s, that slope, you will not be able to get key. So that's why it is important for you to get the line of best fit, for you to get the correct slope, and you'll be able to answer other questions that are under slope. Now the next one is what? The next one is for you to state the two precautions. Actually, the state two precautions you would take if you were if you were to perform this experiment in the laboratory. Just like you can see, this is what is an alternative to practical. It's not the real practical. So for you to actually state the precaution, you should put, I would have avoided. You don't understand, because it is an alternative to practical. It is not actually the practical. So these are the precautions you should have actually write. I would have avoided dropped. I would have noted or corrected zero error on my meter rule, stopwatch, or the stop clock. Some people might actually write stopwatch. Some people might actually write stopwatch, meter rule, and all that. And then the next one, I would have avoided error due to parallax. You know, parallax error and zero error, they are not the same. Do you understand? So in the reading, the meter rule, the stopwatch, and the stop clock. Now, after we are done with 1A, we have to do 1B also. That's actually how you can get all the marks that are allocated for that one question. Now, this very 1B, we were told to what? To explain the term frequency of oscillation of a system. Actually, what they do is that after the alternative to practical, you would actually have to sit back and think on what you've actually known about that very topic. That's this very frequency of oscillation of a system. Now, you have to think. It's not like you just trying to see if you can rule and all that to get the answer. No. Now talking about this very frequency, frequency equals to what? Let's just start. Let's start from that. I want you to use the formula to get the answer to this very question. Now talking about frequency. Frequency is what? Frequency is actually 1 over what? Over the time. That's what? The period. Do you understand? And you know that period is equals to what? I know that our period, and you know that our period is equals to what? Is equals to t over n. Do you understand? That's t over n. So that means that what? This very frequency also will be what? Will be n over t. That's this very t represents what? It represents time. That's what? In seconds. And actually, when we're talking about this, you know that what? The unit of frequency is what? The unit of frequency is what? Is in Hz. That's what? Hz. So after you've known this, what you should actually see is that what? N over T. Actually, when I'm talking about frequency, frequency is the number of oscillation. When I'm talking about that bit N equals to the number of oscillation. So N is the number of oscillation, right? So frequency is the number of oscillation per unit time. Per unit time. Or you can see it like this, that the frequency of oscillation of a system is what? It is the number of oscillation, that's N, completed by the system in 1 second. Now, the second part of this very question. A meter wire of 2 grams at length 50 centimeter is placed under a tension 100 Newton. Calculate the fundamental frequency. To solve this very question, you need to understand this very formula. We have F, that's our frequency, equals to 1 over 2L. Now we have root T over, now you can write it as M, you can write it as M over M over L. But just note that all these very things that you can actually see here, okay, let me use another color. That just note that all these things that you can see here, I want to divine it too. I want to divine it. This M over L now, it means what? It means the linear density of that very what? Of that very wire. So linear density, linear density of that very wire, of the wire. Do you understand? And what of T? T is the what? T equals to the tension. It is the tension in the wire. And how about the L that we can actually see there? Both the L you can see here and the L you can see here. That's the what? That's the what? The length of that very string. Of that very wire. So the length of the wire. Now when I'm talking about the F, I expect you to know that that's the what? Fundamental frequency. Now let's solve the question. So far we've actually known the formula. So to solve the question, just substitute the value of F and all that to it. So F will be equals to what? F will be equals to 1 over 2L. 2 over L. 1 over 2. 2. So what is our L? We have our L to be what? We have our L to be 50 centimeters. And you know that we can't actually use 50 centimeters because 50 centimeters is not the SI unit. You must convert it to the standard unit. Now to convert to the standard unit, that 50 centimeters must be divided by 100 for us to get meters. So 50 divided by 100 will give us what? 0.5. So you multiply that with what? You multiply this with 0.5. You understand? Now, root of 1 over okay. I said 1. It's not 1, it is 100. I'm sorry. The tension is 100. It's actually clear in that very question. And we also have, what is our M? Our M is the mass. And you know that the mass is 2 grams. You can actually use 2 grams. You have to convert it to the SI unit. And the SI unit of what? Of mass is what? Is in kilograms. So that means that you want to convert it to a kilo, like in form of kilo. You have to divide it by what? 1000. So 2 divided by 1000 will give us what? 0.002. So we can just write 0.002. Now divide that 0.02 by what? By 0.5. Where do I get that 0.5? That 0.5 is the same length that we used the other time. I told you the other time. Now, to solve this very question, it's a very simple question now. So, if you actually F equals to what? 1 over If you actually multiply 2 by 0.5, you get 1. Do you understand? So just write 1 here. So that means we have 1 outside. And all over 100, you divide 100 by what? By 0.00 22, like this very 0.002 divided by 0.5. Now, quickly use your calculator to get this very value. If you use your calculator, you will get the this to be what? To be the root of what? Of 25,000. The root of 25,000. Now, uh, and if you use your calculator to get the what's the meaning of this very root, you get 158 point what? Point 11113. Do you understand? Now, what should I write after this 113? Should I just leave it like that? No, you can't leave it like that. So you have to write the unit. So that's what? H Z. Do you understand? So that's the answer to this very question. I think with this, you should understand how alternative to practical questions would be. Do you understand? So with this, you should be able to ace that very examination and pass them all. Actually, it is not only one questions that will be given. You'll be given like 3 questions. You see, you'll be given questions on light, on electricity, uh, on light, like light on electricity, and like pendulum. So just understand those questions. I wish you success in your examination. And if you need more videos like this so that you will be able to prepare for your exams, you can click the red subscribe button below this very video, and also click the notification bell so that whenever I upload those videos, you'll be the first to see them and you'll be able to get them and watch them just for free. Don't forget to invite your friends, and also uh, if you need more physics video that will help you to prepare for your exams, you can click one of the videos you can see on the screen right now. They are what? They are actually certified. They actually well prepared to 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 help you in that very examination. I'll see you next time. Bye.